Our learning objective for today, students will graph quadratic equations in, that should not say standard form, it should say intercept form. Okay, so again, our learning objective, students will graph quadratic equations in intercept form. So let's review standard form. During this set of notes, if you guys have your graphing definition sheet, okay, the one I have pulled up here, you will need to reference it for some of these problems, okay? So keep that guy handy because I will be referencing this throughout the notes, okay? So standard form, let's recall we need to find the axis of symmetry first. And if we go here, the axis of symmetry in standard form is used by the formula x equals negative b divided by 2a. So let's recall we find a, we find b, we find c. A is 2, b is 8, c is 1. Okay, so if you weren't too sure how to find that, okay, that's a, and this is b. Okay, now C we don't really need, but it's good to identify C because that'll come into play a little bit later on. Okay, so now we just plug it into our equation. X is equal to negative b divided by 2a. And remember, b we said was 8 and a we said was 2. So x is equal to negative 8 divided by 2 times 2. Okay, so all we did was we just plugged in those values. So now we simplify, we get x is equal to negative 8 over 4, x is equal to negative 2. Okay, so this is our axis of symmetry, and remember on our table, that goes directly in the middle. Okay, now we want to find two values that are directly smaller than negative 2, so negative 3 and negative 4, and two values that are directly larger than negative 2, so negative 1 and 0. Okay, then, excuse me. Then we need to take all these values and plug them into our equation. Y is equal to 2x squared plus 8x plus 1. Okay, so let's go ahead and see what that looks like. So we're going to start off with negative 4. We're going to plug that in wherever we see an x. So y is equal to 2 times negative 4 squared plus 8 times negative 4 plus 1. Okay, so now we simplify. Y is equal to 2 times negative 4 squared, which is 16, plus, 8 times negative 4 is negative 32, so minus 32 plus 1. Y is equal to 32 minus 32 plus 1, which is just equal to 1. Okay, so our first ordered pair, our x comma y, is going to be negative 4 comma 1. Okay, so we can hold that or write that off to the side. Okay, next we're going to plug in negative 3. So kind of the same idea wherever we see an x. So y is equal to 2 times negative 3 squared plus 8 times negative 3 plus 1. Okay, so y is equal to 2 times 9 minus 24 plus 1. I kind of wrote too big there, so let me shift this up just a little bit. Okay, and then we have y is equal to 18 minus 24 plus 1, which is equal to negative 6 plus 1, which is equal to 5. So then our next ordered pair is going to be negative 3 comma 5. Okay. Let me just look at something really quick. Where did it go? Sorry guys, give me a second here. I'm trying to find something. No. What? All right, we'll just continue on from here. I was looking for my answer key, but I can't seem to find it. Okay, actually, I found it. All right. All right, let's continue. So now we're going to plug in negative 2. Okay, so same idea. Y is equal to 2 parentheses negative 2 squared plus 8 times negative 2 plus 1. Y is equal to 2 times 4 minus 16 plus 1. Y is equal to 8 minus 16 plus 1, which is equal to negative 8 plus 1, which is equal to negative 7. So our next ordered pair is negative 2 comma negative 7. Okay, and then if you guys remember our pattern from the other day, these two guys should match, so this should also be 5. And these two should match, so this should be 1. But we need to double check to make sure we're doing things correctly. And I think I made a mistake. Yes, I made a small mistake. This should be negative 5 here. Negative 6 plus 1 is negative 5, so this should be negative 5. Okay, but we should still double check our work just to make sure we're doing things correctly. All right, so y is equal to 2 times negative 1 squared plus 8 times negative 1 plus 1. Y is equal to 2 times 1 minus 8 plus 1. Excuse me. Excuse me. Y is equal to 2 minus 8 plus 1, which is negative 6 plus 1, which is indeed equal to negative 5. So our next ordered pair is negative 1 comma negative 5. Okay. Lastly, we plug in 0. So y is equal to 2 times 0 squared plus 8 times 0 plus 1. Well, 2 times 0 squared, that's just going to be 0. 8 times 0 is just 0 plus 1. Well, 0 plus 0 plus 1 is just 1, which is indeed the same value we got. So our next ordered pair is 0 comma 1. So let's go ahead and graph these out. So negative 4, 1 is right here. Negative 3, 5 is right up here. Or I'm sorry, negative 3, negative 5 is right down here. Negative 2, negative 7 is right down here. Negative 1, negative 5, and 0, 1. Okay, and then now we can connect our points just like that. Oops. Try to make yours look nicer than mine. Okay, this should be kind of like a U shape. So for those of you guys using Notability, if you hold the graph after, you can drag things around and make it look nice and neat. Just like that. Okay. All right, now the fun part, filling out all this information. So what was our A value? Well, A was 2. And let's recall from our graphing definition sheet, A tells us how the graph opens. So if it's positive, that means it opens up. So we're going to write it opens up. Why does it open up? Because A is positive. Okay. Now the shape. Now again, if we look at our graphing definition sheet here, the shape, okay, you take the absolute value of A. If it's equal to 1, it's normal. If it's greater than 1, it's vertical stretch. If it's less than 1, it is vertical compress. So if you take the absolute value of 2, that is equal to 2. So it is greater than 1. So we say this is a vertical stretch. Okay, why? Because the absolute value of A is greater than 1. The axis of symmetry, well, we found that earlier. Okay, that was negative 2, but we need to say x equals negative 2. The vertex is our middle point, so negative 2 comma negative 7. Is this going to be a min or a max? Well, how do we know? We also have it on our sheet here. We talked about it yesterday. We said that it is a max if the graph opens down, and it is a min if the graph opens up. Well, our graph opens up, so this is going to be a min, or a minimum. The domain, it's also on our sheet, okay? The domain is all the possible x values that satisfy the function, and it is always going to be negative infinity, comma, infinity, with parentheses. So negative infinity, comma, infinity. Now the range, on the other hand, that is going to be a tricky one, okay? So let's reference our sheet here. The range, okay? It's all the possible y values that satisfy the function. If your graph opens up, okay, this is how we, since our graph opens up, this is how we, oops, that's not what I wanted. What's going on? Okay, so, whoa, not too sure what's going on there, but our range, the graph opens up, so this is how we write our range. Okay, we start from the lowest y value to the highest y value. So looking at our graph, my lowest y value is right here, which is negative 7. So we're going to go square bracket, -7. And then our graph goes up forever, so that goes up to infinity. Okay? Oh, that's why. Okay. So now let's look at our end behaviors. Okay. Now for every graph that opens up, the end behaviors are always going to be the same no matter what. Okay. So let's talk about the end behaviors a little bit more just to refresh our memory. So if we're on the x-axis and we keep going to the right forever, eventually we will get to infinity. So as we go towards infinity on the x-axis, we want to know what is this side of the graph doing on the y-axis. Well, on this side on the graph, it is going up forever. So going up forever means we go towards infinity. So the right side end behavior, as x approaches infinity, y approaches infinity. Okay, and the same idea on the left side. So as we go to the left forever on the x-axis, well, eventually we will get to negative infinity. I want to know what's going on here. Well, on this side, this is also going up forever. Okay, so if we go up forever, that is infinity. So for the left-hand side, we're going to say as x approaches negative infinity, y approaches infinity. And your end behaviors will always be the same for every quadratic that opens up. Okay, so that was our quick review of standard form. Okay, now we're going to get into intercept form. To graph this in intercept form, let's quickly refer to our sheet over here. Okay, here's intercept form. Okay, and oops, what's going on here? Whoa, okay, so I guess I can't write. Oh, that's okay. So intercept form, y equals a times x minus b times x minus q. Okay, a lot of the information is still the same. We still have our a value. We still have to find the axis of symmetry, which, by the way, in intercept form, the axis of symmetry is the midpoint. Okay, well, how the heck do we find the midpoint? Well, that's a good question. We're going to use something called the zero product property. Okay. Now, the zero product property says you take every part in your equation that has an x, so this guy, x plus 3, and this guy, x plus 7, they both have x's, and we're going to set those equal to 0. So we're going to go x plus 3 equals 0, and x plus 7 equals 0. We solve for x on each side, so here x is equal to -3, and here x is equal to -7. Okay, we can call this guy x1 and we can call this guy x2. Now the midpoint says is the following formula: x1 plus x2 divided by 2, or x equals x2 plus x1 plus x2 divided by 2. So let's go and plug in our values. So -3, that's x1, plus -7, that's x2, divided by 2. This is going to be -10 divided by 2, which is -5. Okay, so this is our midpoint. And another word for the midpoint is also the axis of symmetry. Okay, so we can also call this the AOS, or axis of symmetry. Okay, and again, just like before, that will go in the middle of our table. Okay, now just like before, we're going to pick two smaller values, so -6, -7, and two larger values, -4, -3. Now something nice happens in intercept form. Okay, notice that we already have the value of -3 right here, and we have the value of -7 right here. Okay, since we set those parts equal to 0 earlier, we already know those y values. Those y values will automatically be 0. Okay, and remember our pattern from standard form: the first and the last value should be the same. So that's the case here. It does hold. So now that lessens our work, and we only need to check -6, -5, and -4. So let's go ahead and start checking these. Let's find those y values. So we're going to plug -6 into our equation. Y equals 2 times x plus 3 times x plus 7. So y is equal to 2 times -6 plus 3 times -6 plus 7. Y is equal to 2 times -3 times 1. So y is equal to -6. Oh, and I forgot we should write our ordered pairs. So x comma y, our first ordered pair is -7 comma 0. Our next ordered pair is -6 comma -6. Our next ordered pair, well, let's figure that out. So now we're going to plug in -5. So y is equal to 2 times -5 plus 3 times -5 plus 7. Y is equal to 2 times -2 times 2, which gives us y is equal to -8. So our next ordered pair is -5 comma -8. Okay, and remember, just like in standard form, our pattern should hold. These two should be the same. So that the next value should be -6. But we should still double check. Okay, so we're going to go ahead and double check. So we're going to plug in -4. So y is equal to 2 times -4 plus 3, -4 plus 7. Y is equal to 2 times -1 times +3. Y is equal to -6. So yes, this did work out. So -4 comma -6. And our last ordered pair, -3 comma 0. Okay. Now let's go ahead and start graphing these. So we have -7, 0 right here. -6, -6 right down here. -5, -8 right here. -4, -6 there. And -3, 0 here. Okay, so now we can connect our points. And for those of you guys using Notability, if you hold this, it should make a nice looking graph like that. And then you can adjust your points. Okay, just like that. Now, just like we did with standard form, we also want to find all of this information in intercept form. It's done very similarly. So we start off with our a value. Well, a is, if we look at our reference sheet, right, intercept form, a is given to us right here. That's our a value. So our a is going to be 2. Okay, so that doesn't change. So a is 2. That still tells us the graph opens up. Okay, why? Because a is positive. Okay, and then since a is 2, that also tells us the shape. So let's go over here. Again, we take the absolute value of 2. So if it's equal to 1, it's normal. If it's greater than 1, it's a vertical stretch. If it's less than 1, it's vertical compressed. If we take the absolute value of 2, that is equal to 2. So that is greater than 1. So this is a vertical. What did we say it was? Vertical stretch. Why? Because the absolute value of a is greater than 1. The axis of symmetry, that was x equals -5. Okay, and then now this time we want to list the vertex, which is going to be -5 comma -8. And because our graph opens up again, okay, since our graph opens up, it's going to be a min or a minimum. Okay, now this is the new part here, the x-intercepts. Okay, the x-intercepts is where your graph crosses the x-axis. So if this is my x-axis here, where does the graph cross the x-axis? Well, we cross the x-axis in 2 points. We cross here and we cross there. So those are the x-intercepts. So we're going to put down those ordered pairs, which were -7 comma 0 and -3 comma 0. Okay, and then the domain, just like always, -infinity comma infinity. The range, okay, let's do this very carefully. The range, okay, is right here. So our graph opens up. So we start with the lowest y value with the square bracket to infinity. So let's look at our graph. Here's my lowest point. So the lowest y value is -8. Square bracket, and we go up to infinity. The end behaviors as before, okay? So we want to know as we approach, as we go forever on the x-axis that way, we will eventually get to infinity. Then we want to know, what is this side of the graph? What's that going up towards? Well, we're going up forever. Well, what's up forever? That is also infinity. So as x approaches infinity, y approaches infinity, and that represents the right side end behavior. Now we're going to do the same thing on the left side. So as we go this way forever, well, that is -infinity. Well, what is this side of the graph doing? Well, that is going up forever towards infinity. Okay, so as x approaches -infinity, y approaches infinity. Okay, and that's how we graph intercept form. Okay, let's go over our next example here. Okay, so now before we even do anything, let's point some things out. We can kind of fill out some information without doing much. Like for example, our a value. Well, what is my a value going to be? Well, what number is right here? Well, that would be -1. So what does that tell us about how the graph opens? Well, let's look at our sheet here. If a is negative, that means the graph opens down. Why does it open down? Because a is negative. Okay. Now, we can also find the shape, right? So if we know that a, let me write it down here, a equals -1, we take the absolute value of -1, that is equal to 1. So for the shape, it's going to be normal. Okay, why? Because the absolute value of a is equal to 1. Now the axis of symmetry, well, we need to do some work here, because remember the axis of symmetry in intercept form is the midpoint value. So we need to find the midpoint. So we're going to use the zero product property again. We're going to take every piece that has an x, so that piece and this piece, set them equal to 0. X minus 1 equals 0, and x plus 3 equals 0. Okay, solving for x, we get x equals 1, and x equals -3. We'll call this guy x1 and x2. So now we find the midpoint. Okay, remember that was x is equal to x1 plus x2 divided by 2. So this is going to be 1 plus -3 divided by 2, which is -2 divided by 2, which is equal to -1. Okay, so our axis of symmetry, or the midpoint, is -1. So now we need to find two numbers smaller, two numbers larger. So two numbers smaller are going to be -2, -3, and 0 and 1. And just like before, notice that, hey, we have 1 here. It's right here. So this value will automatically be 0. And then also notice we have -3 here. So this value will also be 0. Okay, and then now we just need to check -2, -1, and 0. So let's go ahead and plug in those values. So y is equal to negative times x minus 1 times x plus 3. So let's go ahead and plug in -2. So y is equal to negative parentheses -2 minus 1 times -2 plus 3. So y is equal to negative, and this is -3 times 1. -3 is +3 times 1 is +3. Oh, and I forgot to list the ordered pair. So x comma y, this is going to be -3 comma 0. This will be -2 comma 3. Okay. And let's go ahead and check the next one. Okay. So next we're going to plug in -1. So y is equal to negative parentheses -1 minus 1 times -1 plus 3. Okay. So y is equal to -2 times 2. Y is equal to, well, negative times -2 is +2 times 2 gives us 4. So our next ordered pair will be -1 comma 4. Okay, then remember our pattern from before. These two values should be the same, so this should be 3, but we still need to double check. So let's go ahead and double check here. Okay, so let's go ahead and plug in 0 now. So y is equal to negative parentheses 0 minus 1 times 0 plus 3. Y is equal to -1 times 3. Well, -1 is +1 times 3 is +3. So this is 0 comma 3. Then our last ordered pair is 1 comma 0. Okay. So let's see if we can start to graph and then fill out the rest of this information. So -3, 0 is right here. -2, +3 is right here. -1, 4 is right there. 0, 3 is here. And 1, 0 is right here. And now we can make our graph or connect our points. And again, you can hold this in Notability and it will automatically adjust just like that. Okay. All right, so now our axis of symmetry, that was x equals -1. Our vertex, -1 comma 4. Is this a min or a max? Now this time our graph opens down, so this will be a max. The x-intercepts, remember we said the x-intercepts is where it crosses the x-axis. So where does our graph cross the x-axis at? Well, we cross at 2 points. We cross here, and we cross there. So that will be -3, 0, and -1. I'm sorry, not -1, +1, 0. Okay, and then our domain is always the same, -infinity, infinity. And then the range, so now let's be very careful with our range. Okay, our range, this time the graph opens down, so we start with -infinity, parentheses -infinity, to the highest y value with a square bracket. Okay, so let's see what that looks like. Okay, so we start with our parentheses, -infinity, and then now we want to know what is the highest y value. Well, this is my highest point. This must be my highest value. So it's going to be -infinity to 4 with a square bracket. And then our end behaviors this time. Okay, so let's see if we can match that up. This time our graph opens down, so our end behaviors will always be the same like this. But let's go ahead and talk about it. So as we go forever on this side of the x-axis, we will reach infinity. We want to know what's going on here on this side of the graph. Well, that is going down. Well, what's down forever? -infinity. So as x approaches infinity, we say y approaches -infinity. Same idea on the other side. So as we go to the left forever, we get to -infinity. We want to know what's going on this side of the graph. Well, hey, this is going down forever. So down forever, that is -infinity. So as x approaches -infinity, y approaches -infinity. And that's exactly what our end behavior for any graph that opens down will be. Okay. All right. So again, remember, this is a video. So at any point you need to pause, rewind, rewatch, please do so. Okay. Our next example, I would encourage you guys to pause the video, try this one out on your own, and then come back and try to see if you got things correct. Okay, but for the time being, I am just going to kind of give you guys the answers here. Well, actually, no, I'll just work through it. I guess that's fine. So let's go ahead and work through this. So we're going to go ahead and do the midpoint. So we're going to go x plus 1, set that equal to 0. X plus 5, set that equal to 0. Solve for x. X equals -1. X equals -5. Now we do the midpoint. Okay, so x is equal to x1 plus x2 divided by 2, which is -1 plus -5 divided by 2, which is equal to -6 divided by 2, which is equal to -3. Okay, so -3 is our axis of symmetry and the midpoint. Pick two smaller values, -4, -5. Pick two larger values, -2, -1. Okay, and again, we notice that we already have -5. So this should be 0. We already have -1. That should be 0. And we just need to plug in -4, -3, and -2. I will leave that up to you guys to do, to verify. But when you do, you should get 6, 8, and 6. Okay. So now we have our ordered pairs. -5, 0. -4, 6. -3, 8. -2, 6. And -1, 0. So let's go ahead and graph. So -5, 0. -4, 6. -3, 8. -2, 6. And -1, 0. So now we can connect our points. And again, for those of you guys using Notability, you can make this look nice and neat. Okay. Now our A value, well, what was our A value here? Our A value was -2. So that means the graph opens down. Why? Because A is negative. Okay, the shape, that will be a vertical stretch. Okay, now again, you can verify that. Okay, here, take the absolute value of -2. It's +2, which is greater than 1, so that's why it's a vertical stretch. Okay, why? Because the absolute value of A is greater than 1. The axis of symmetry, x equals -3. The vertex, -3, 8. Is this a min or a max? Well, let's recall the graph opens down, so this will be a max. Okay, the x-intercepts, where does our graph cross the x-axis at? Okay, well, we cross the x-axis at these 2 points. We cross here and we cross there. So -5, 0 and -1, 0. Okay, the domain is always the same. -infinity, infinity. That will never change. Now the range does change. So let's talk about the range. Okay, when the graph opens down, we start with -infinity to the highest y value, square bracket. Okay, so we're going to start with parenthesis, -infinity, and then the highest y value. Well, this is my highest point. This is the highest y value. So 8 with a square bracket. And then our end behaviors, again, if we go to the right forever, that will be infinity. Okay, so we want to know, as we go to the right forever, what's the right side of the graph doing? Well, that is going down forever, so that will be -infinity. So the right side end behavior, as x approaches infinity, y approaches -infinity. Now let's do the same thing on the left side. So as we go to the left forever, that is -infinity. We want to know what's going on the left side of the graph. Well, that is also going down forever, which is -infinity. So the left side end behavior, as x approaches -infinity, y approaches -infinity. Okay, so again, remember this example, I kind of wanted you guys to kind of work out and then come back and see if you did things correctly. All right, so with that being said, this is your practice work. Okay, so you have some review of factoring. Okay, so don't forget how to factor, because factoring does come into play. We're graphing one intercept form and graphing a standard form. Okay, and that's it.